So here we have section 1.4, parametric equations. So there's our objectives. So a couple definitions. So a relation is a set of ordered pairs x, y of real numbers. The graph then is the set of the points in the plane that correspond to the ordered pair if x and y are functions. With a third variable t, called a parameter, then we can use parametric mode of a grapher to obtain the graph of the function. So example 1 down there says, describe the graph of the relation determined by x equals root t, y equals t, and t is more than 0. So we're just going to do this with a really brief graph. So when you do this, you actually need 3 columns, t, x, and y. Now, since I'm going to be taking the square root, I want to pick values of t that are perfect squares. So we'll do like this, 0, 1, 4, 9, because x then is going to be the square root of t, which is 0, the square root of 1, which is 1, the square root of 4, which is 2, the square root of 9, which is 3. Then this column is actually just the same values because they're a t. So I didn't really leave myself a whole lot of room here. So 0, 0, 1, 1. So when you plot them, you're only plotting the x, y values. So 2, 4, so it looks something like that. All right, I indicate the direction, so that went that away. So to find a Cartesian form, what you do is you take your x equals equation, so x equals root t, and you solve it for t, which means I'm going to have x squared. Now if t is equal to x squared and y is equal to t, I can say that y is equal to x squared. So I just plug x squared in for the t in the y equation. Now I do have a restriction where t is more than 0. So I need to convert my t values into x values. So to do that, I take the square root, which is 0. So x must also be greater than or equal to 0. These are a parametric curve. The 2 equations are the parametric equations. And then down here, we've got a whole lot of definitions. So the variable t is the parameter. Domain I is the parameter interval. If it's a closed interval, then you have initial point and a terminal point, where A gives you the initial point and B gives you the terminal point. So you could turn a Cartesian equation into a parametric. That's referred to as parameterizing, and then it's for the parameterization of the curve. All right. So for circles here, so for x equals a cos t and y equals a sin t, you can do this substitution. So you can replace a cosine for x and a sin in for y. So when you square them, it goes to both values. You can then factor out an a squared. This term is equal to 1. It's a Pythagorean identity, so it's equal to a squared. So it says here, describe the graph for the relation determined by x equals 2 cos, y equals 2 sin. For the initial and terminal points, if any, determine the direction which the curve is traced. Find a Cartesian equation for the curve. So we'll do t, x, y. Now, since I have trig functions, I'm going to use these values because these are the ones that go with trig functions. So 2 times the cosine of 0 is 2. This is 0. That's negative 2. That's 0, and that's positive 2. This is 0, 2, 0, negative 2, 0, if you work them out. So if I plot my points, 0, or 2, 0, 0, 2, negative 2, 0, 0, negative 2, and then back here. So I went around that a ways. So the initial point is right here. And then here we also have the terminal point. So they're actually the same values. Find our Cartesian equation for the curve. Now there's a kind of a shortcut here. So if you look at this up here, so there's my x squared plus y squared. And it's going to equal the coefficient squared. So the coefficient was 2, so it's going to equal 4. So this is actually an equation of a circle with radius 4. All right, so you can also do the same thing with ellipses, except you have this formula. So graph the parametric curve, x equals 3 cos, y equals 4 sin for those values. So same t-table. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when x is 0, this is 3, this is 0, this is negative 3, this is 0, this is 3. And for y, this is 0, 4, 0, negative 4, 0. So if you notice, my numbers aren't quite the same. So 3, 0 is right there. Then 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. and then go around that way. So there's the direction. So there's that, and then to get it, so you have x squared plus y squared, so they're each over something equal to 1. So a squared is the coefficient on the x squared, so that's going to be 9. B is the coefficient on the y value, so that's going to be 16. All right, so example 4, draw and identify the graph of the parametric curve determined by that equation. So we'll do our, so t, x, y. So t has to be between 0 and 1, so we'll just use those values. So for x, 0, so over here you have 3t. So 3 times 0 is 0, and 3 times 1 is 3. For the y's, 2 minus 2t. So if t is 0, that's 2 minus 0, which is 2. And when t is 1, that is that. And then we'll do our little sketch. So the first point is at 0, 2, so that's right there. And 3, 0, 1, 2, 3, that's right there. And then we just connect the dots. Now we can't go outside the dots because t has to stay in between those values. So there's my graph. If you wanted to solve it into the Cartesian form, you'd have that. So divide, so t is equal to x over 3. And then I'm going to take my y equation and plug that in. So that would be the equation in Cartesian form. Okay, so for example 5 here, so we need to find the equation, the line that passes, that connects those 2 points. So first I need to find the slope, so 5 minus 1 over 3 plus 2. So it's y minus y over x minus x. That becomes positive because I'm subtracting a negative. So that's 4/5. So the equation of my line is 4/5 x plus 2 plus 1. So 4/5 x plus 8/5 plus 1. So that's 13/5. All right, so there's my regular form. Now to make a parametric, I need an x equals equation and a y equals equation. So the easiest way to do this is just set the x value equal to t. And then the reason you do that is then the y equation just becomes the exact same thing except with a t instead of an x. So you have that. Now there is one restriction. I need to restrict this because it's a line segment, so t has to stay between a couple values. Now since x and t are the same thing, t has to stay between the same values as I have over here. So t has to be between -2 and +3. So this right there would be your solution, the x and y equation with the restriction. Looks like that's the end of the section.